Andrew Ng, the founder and executive chairman of Landing AI, and our only virtual speaker of the day, is virtually here to talk to us about how a new set of design patterns is emerging with the rise of AI agents and agentic reasoning. Andrew, are you there?
Yes, I'm here. Good to see everyone. What I hope to share with you today is some trends I find exciting in AI agents and applications. Should I be? So I think that you may have heard me say that AI is the new electricity, because I think AI, like electricity, is a general purpose technology, meaning it has a lot of use cases. And so a lot of the important work ahead of us is to identify and build those applications. People often ask, where are the biggest opportunities in AI? And this is what I think of as an AI stack. At the lowest level is the semiconductor layer. Clearly, NVIDIA and so on have been doing well. On top of that is a cloud layer. And then on top of that, the foundation models. And whenever there's a new wave of technology, the media and social media and buzz often focuses on technology layers, kind of these layers, and there's nothing wrong with that. But it turns out that for these layers of the stack to do well, almost by definition, there's another layer of the stack that had better do even better, which is the application layer, because we need the applications to generate even more revenue so that they can afford to pay the technology layers underneath them. So a lot of my work is actually the applications layer, and I think hopefully a lot of people's work will be building applications using these technologies. And speaking of applications, I think a lot of applications of AI are much easier to build than ever before. So here's a fun example. Could you play the audio?
ScaleUp AI, dreams take flight, they touch the sky. Agents meld with text so bright. VC takes a chance tonight. Entrepreneurs hearts on fire. Bold visions, goals they
Feel free to
aspire.
dance.
AI whispers past to take new chances we will make. Celebrate the mind so keen. Build a future's new machine. Investing in a sky so blue. New worlds we will pursue. Data dances in the night.
I hope people could hear that. So yeah, I find that we spend a lot of time talking about how AI makes us more productive, and that's important. We'll talk about that. For myself, I find that AI makes my life more fun too, and maybe that's important as well. What I want to do is touch on a few AI technology trends that I think are important, and then share a little bit about how I see not just startups, but also large enterprises are taking advantage of this. In terms of AI trends, if you were to ask me what is the most important AI technology trend, I would say is agentic AI. So pay attention to only one technology, I'd say pay attention to this one, which is that a lot of us have been using large language models with a non-agentic workflow where we would write a prompt and have it generate a response. And one way to think of that is if you imagine going to a human, or in this case, going to an AI, and asking it to write an essay for you on a certain topic by typing the essay going from the first word to the last word all in one go without ever using backspace. And humans don't do our best writing like that. And AI, despite the difficulty of being forced to write in this completely linear fashion, maybe does surprisingly well. With agentic workflows, this is what we can get AI to do. We can ask it to maybe write an essay outline and then ask if it needs to do any web research. If so, let's download a few web pages, put that into the large language model input context, then have it write a first draft, have it read over its draft and decide what needs revision, have it revise the draft, and so on. So this workflow looks more like doing some thinking, some research, and then doing some revision, and then some more thinking, some more research, and going around this loop over and over allows it to generate a much better work product. When I started to talk about agentic workflows near the beginning of this year, I think it was still an emerging technology. It was maybe controversial that I was really betting on it. Now it's interesting that it's become almost a marketing term of hype, but I think there is real technical substance, and building these iterative agentic workflows, I am seeing deliver a much better work product for many applications. But just to share with you one example of results from many different teams, my team collected some data from a coding benchmark. The benchmark's name is human eval, but it just evaluates how well an AI system is able to write code to solve the low coding puzzles. And it turns out that GPT 3.5 with a non-agentic workload, where you also just type out the code, please, it gets it 48% right on this benchmark. There's a Parser-K metric, I think. GPT-4, 67%, much better. But the improvement from GPT 3.5 to GPT-4 is dwarfed by the improvement from GPT 3.5 to GPT 3.5 using an agentic workload. And GPT-4 with an agentic workload also works much better. And what I'm seeing is in one of my team's AI fund, we're seeing agentic workloads really make a decisive difference in how we can process tricky legal documents or help with medical diagnosis assistance or build algorithms to fill out complex kind of tricky government compliance paperwork. And so for many applications, seeing these agentic workloads make a very large difference. And so to take the slide and update it, I think that while this has been the AI stack picture for a long time, there's actually a new emerging layer, which is the orchestration layer that is becoming increasingly agentic. There have been tools like LangChain, they've been around for a while, but LangChain is evolving to more work on LangGraph, which is increasingly agentic. I think Joe Mora is speaking later today. I made a small personal investment in Crew AI. I was excited that Insight Partners invested too. Fantastic framework for building agents. I think this agentic orchestration layer is making it even easier for people to build applications. Having said that, the conclusion that I raised at the start, I don't think that changes. I think most of the value had better be at the application layer, but these other layers are also emerging and exciting. One of the things that one of my team does, Deep Learning AI does, is we're privileged to work with pretty much all the leading Gen AI companies, including Crew AI, I should say, with Joe speaking a little bit. To create courses for training developers on a variety of AI tools. And I find that this, I find the space of tools increasing rapidly and is letting many people build applications much more easier than was ever before. I think there's a lot going on in AI, and it's impossible to summarize everything going on in AI in just one slide. But what I thought I'd do is just summarize what I think are 5 of the most important trends in AI. Knowing I can't summarize all of AI in 5 trends, but I want to share a few things that may be important to, I think, many of you in the room. So first, agentic workloads, it turns out they generate and read a lot of text, or we say a lot of tokens. And so it will benefit from faster, cheaper token or cheaper text generation. So I find the new semiconductor work, my companies like SambaNova, Cerebras, Grok, and a few others to be exciting. And the ability to speed up the rate at which LLMs can produce text will be important. Previously, you might wonder, why do I need my AI model to generate text faster than any human can read? Well, if it was the human consumption, maybe you don't need it to generate text 10 times faster than human consumption. But agentic workloads can iterate and run for a long time. So if I can take my 20-minute agentic workload and speed it up to 5 minutes, that's actually a huge value add. So that's one important trend. Second, generative AI is making it possible to prototype very efficiently. And this is changing the corporate innovation process, both in small startups and in large companies. So back when we're using many supervised learning to train AI models, this is what the workflow may look like. Get data, train a model, deploy it. Maybe it'll take 6 to 12 months. And this was fine. It built a lot of very valuable AI applications. But for some of these applications, with large language model-based development, we can write a prompt and deploy at least a prototype in maybe 10 days. So the fact that there are a lot of systems that used to take me or very good AI teams, 6 to 12 months to build, that today many teams can build in maybe 10 days. This is putting a lot of this is really speeding up the corporate innovation process. It turns out that of all the things needed to build an AI system, maybe the machine learning modeling piece is the one that's become much faster. There are other parts as well, like product design, integration, guardrails, compliance. There's some other steps that can still take a while, but the fact that the AI step has sped up so much is putting a lot of pressure for the other parts to speed up as well. And it is actually now a viable strategy for a lot of businesses to decide, if the cost of prototyping is so low, let's just build 20 prototypes and see what sticks, right? And it's fine if 18 of them fail. I think in tech, the mantra "move fast and break things" had gotten a bad rep because it broke stuff. And I think some people took away from this that we should not move fast, but I disagree with that. I think the mantra is move fast and be responsible. And with this capability to build prototypes really quickly, I see a lot of teams able to put in place the processes to move fast and also be responsible and not ship stuff that causes material damage to anyone. Let's see. I think the text processing revolution has arrived. The image processing revolution is coming and will enable many visual AI applications. So I see a lot of companies, especially large companies, with tons of image or video data maybe stored in blob storage somewhere and just don't know how to get value out of it. But with large multimodal models and visual AI agents, there's something that my team, Landing AI, which Insight Partners invested in, thank you, is doing a lot of work in. We can get a lot more value out of the visual data with a vision agent and other things like that. One interesting trend is the gravity of data is decreasing. So it turns out that if you stored all your data in one cloud, it was unthinkable to transmit the data to different cloud for processing. You would never, take a terabyte of data stored in, say, Google Cloud and transmit it to Azure for processing. It's just you just don't do that because the transmission cost is so high. But it turns out Gen AI workloads are so compute intensive, the compute cost dwarf transmission costs. So back to the envelope calculation, transmitting a gigabyte of data, cloud egress costs maybe like 10 cents to transmit a gig. It turns out that processing a gig of data, even on the cheaper models, like say GPT-4 mini, that's going to cost you maybe $30, $40. And so the transmission cost of 10 cents is much lower than the compute cost of maybe tens of dollars. So I'm seeing new design workflows where people are more likely to build applications where we ping packets all over the internet and send the data, across the world for processing because it's so compute intensive that that's actually okay. So this is actually creating a lot of shifts as well with downstream impact. And lastly, data engineering has always been important, but I think its importance is rising again, particularly on management of unstructured data, such as text and images. Previously, a lot of the value of AI was on structured data, kind of numbers, Excel spreadsheets, tables of numbers. But with Gen AI, we can now get much more value out of text and images and maybe audio than we could before. And so I'm seeing a lot of companies re-architect the data infrastructure with a much greater emphasis this time on the plumbing to get the unstructured data where it needs to go, because Gen AI is able to get much more value from this. Again, I feel like I feel like I don't know how to do a good job summarizing all of AI in 5 trends. I feel like I'm leaving out so much, but I think these are 5 significant trends that will affect a lot of businesses. One other thing I want to touch on is corporate innovation in AI. So my team AI fund does a lot of work with large corporations. I know some of you are from large corporations, or many of you do work with large corporations. And I'm often asked, how can big corporates take advantage of these new AI innovations? And so and here's an interesting diagram from a research paper by some friends at UPenn and the collaborators at OpenAI that shows on the x-axis salaries, wages, US dollars, and y-axis is how exposed different job roles are to AI automation or augmentation. The interesting thing about this chart is the curve goes up. So whereas earlier ways of automation tended to automate, lower wage work, maybe think factory automation or industrial automation, the routine repetitive work, this wave of Gen AI is more able to automate knowledge workers' work. And I just want to point out something, the curve does come back down. So I think everyone in this room, I think your jobs are safe. Having said that, there is actually a lot of new opportunities for us to automate or to assist with knowledge work. And one thing I've learned is my team at AI Fund, we're a venture studio that builds about 1 startup per month. And I want to share with you an innovation process that we've really honed over the years that seems to work well, which is I think my team's always talked to a lot of people about a lot of ideas. And I want to illustrate this with one idea, which is a few years ago, a company, Mitsui Corporation, large trading company out of Japan, which operates a lot of large ocean-going vessels. They came to me and said, hey, Andrew, you should use AI to make ships more fuel efficient. So can you use global wind and ocean currents and so on data to recommend to ships how to steer to get them to the destination safely and on time and with less fuel? So this wound up being a startup bearing AI. But when we come across an idea like this, we spend about a month to do deep market validation, make sure there's a market and make sure it's technically feasible. And if it works, we then recruit a CEO. In this case, Dylan Kao, repeat entrepreneur with one exit before, to build a company. And we then spend about 3 months building a deep technical prototype with the CEO. If the company survives, we write $1 million check in, and then the company is off and growing and scaling and so on. And the outcome of this is this is now software running on over 600 ships on the high seas and saving an average of about $500,000 US per ship per year and about 10% CO2 emissions reductions. And I want to point AI person, what do I know about global maritime shipping? I would never have come up with this idea myself. And I think it's often when teams that know AI, working with subject matter experts, Mitsui Corporation, in this case, that's a large trading company, operates or works with many large ocean-going vessels. And it was that combination of our AI expertise and Mitsui's deep expertise in maritime shipping that allowed the co-creation of this new application that I think is, making a meaningful difference out there today. And I often spend time with large corporations. I spend a lot of time with startups. I also spend a lot of time with large corporations because I think to get to scale, the large corporations will be a really critical part of helping AI scale. And so work with large corporates, I'm going to share with you a process that seems to work well, that hopefully maybe will be useful to you too. I'll walk through this 5 steps really quickly. But I found that executive training on AI technology is very helpful to make sure that executive leaders know enough about AI to be able to identify opportunities. So the fastest growing course on Coursera last year was Generative AI for Everyone, which teaches executives or teaches at a non-technical level what AI can and cannot do. And then after key leaders understand even at a non-technical level what AI can and cannot do, I find it useful to then brainstorm what are the AI application opportunities. And large teams will often have ideas. And there's also a recipe pioneered by one of my friends, Eric Brynjolfsson, and his collaborators at Stanford, called a task-based analysis of jobs that I found to be very useful. So it turns out society has often had an important discussion about whether AI will automate jobs. And I think governments and society should think about that because of employment and unemployment. From a business perspective, I find it more useful to think of AI as automating tasks rather than jobs, because jobs are made out of many tasks and AI automates tasks rather than jobs. And so when you take a job, break it down into tasks, kind of look at what all your employees are doing, and then see which tasks AI can help with, then that often leads to ideas for where to apply AI. For example, customer service representatives is a sector being heavily disrupted by AI right now. And it turns out, if you look at the tasks done by customer service representatives, there are some that are at high potential for AI automation or augmentation. And those tend to be, often the easier quick win projects. And there's some that are actually harder for AI to automate. And one interesting lesson, when we work with a business on this task-based analysis, the biggest opportunities, they were often a surprise. It was usually not what we thought, but we found that the systematic analysis really leads to much better conclusions than the gut. And I know that this might seem like a recipe for cost savings because we're going to identify some tasks, use AI to make it 1,000 times cheaper. And if a company takes the cost savings, that's fine, nothing wrong with that. But much more than you would expect, the majority of the time in my experience, companies will instead say, great, if you can make a task 1,000 times cheaper, let me do this task 1,000 times more. And this ends up being a recipe for revenue growth, not just cost savings. And growth is more interesting because often more interesting, right? Because you can only save so much money, but there's no ceiling, right, to how much we could potentially grow. After brainstorming AI projects, I find that we can often carry out diligence on project feasibility to make sure it's technically feasible and also is valuable. And that often leads into a prioritization exercise, kind of a build versus buy versus invest decision. And what I find is that if you can buy, I often advise partners, just buy it. Like, it saves them a lot of time. If it exists in the market, I don't know, just go buy it most of the time. But it turns out that because Gen AI technology is so new, when we go through this exercise, there are well, pretty much always tons of ideas that no one in the market has gone around to build yet. So buying is not an option, and then building is often then whether or not you want to do. And I find that every large company I've worked with has come up with a lot more ideas than you possibly have internal resources or patience or desire to build. And I think there'll be a small number of ideas that if you want to pay for it, be responsible for it, hire your own AI team, maintain it, then build it internally. But if you want the benefits without needing to pay for everything yourself, then spinning it out into an independent startup to do it cheaply and also give you all the benefits you want could be a viable option. So in the shipping example, Mitsui Corporation, they really did not mind that other ships got fuel savings as well. What they really wanted was for their ships, to get those fuel savings. And so, and by spinning it out, it meant that they did not need to hire their own machine learning people and build and maintain their own kind of little shipping AI optimization unit. And then lastly, I think there's a lot of and I find that after businesses get this motion going a couple of times, there's a lot of work in AI strategy as well as workforce training that are good investments for the long term. All right. Before I wrap up, there's just one last thing I want to touch on, which is when I speak with both governments as well as corporations, maybe at the board and CEO level, I'm often asked about AI governance. And the one message I hope I leave you with is to govern applications rather than the technology. So here's what I mean. I think it's important to distinguish between technology and applications. For example, an electric motor is a technology and it can be used in many different applications. So technology are tools that can be applied in many ways to solve problems. Applications are specific implementations that are designed to meet particular customer needs. AI models are like that too. A large language model can be used in a medical device, social media feed, chatbot, or to generate political deepfakes, which maybe we don't want. And it turns out that a lot of the discussions have been on how to govern AI, but I don't think that's where the focus should be. We should be focused on governing the applications because risks depend much more on the application, not on the technology. So for example, if you were to try to govern an electric motor, if you go to an electric motor maker and say, can you make sure your electric motor will never be used in an unsafe application? That just can't be done. Instead, if you go to the application and say, can you make your blender safe? Well, we know what the risk, we can better figure out what the risk factors for a blender. Or can you make your electric vehicle safe? Can you make your dialysis machine safe? So I think governance, safety applied at the application layer makes more sense as technology layer. Same true for AI. I've actually seen over the last year and a half, I was really surprised by the intensity of lobbying efforts by some, often some large companies that had trained large AI models that really did not want to compete with open source software and lobbied intensely for stifling regulations that would have stifled open source AI model technology. Fortunately, many of us work collectively and we've defeated most of the worst of those regulations, but this is something I think we're to stay vigilant on because if you put AI into a medical device, let's figure that out and make sure that's safe. Let's figure out what outcomes we do and do not want at these applications, but regulating or trying to govern AI technology, it makes as much sense as trying to, tell an electric motor maker, right, to guarantee their motor will never be used in a dangerous device, which just is not possible. And I find that at the board level as well, if you think about how to govern the applications, how you use them, that will lead to better conversations and better practices for making sure the AI is safe as opposed to governing the raw technology itself. So just to wrap up, I think AI, because of agentic workflows and other things, is rapidly expanding the set of things that is now possible. And I think this creates tremendous opportunities for fast-moving startups as well as for large companies. And so thank you all very much.
You're my GPU. Ooh, yeah.